All right, so the first thing, besides just recognizing whether things are systems of equations or not, which we said it's two or more equations, right, with the same variables. Like that one had x's and y's. These two only have one equation. That's not a system of equations, obviously. And that one had different variables. That's what we mentioned the other day. All right, so if the first thing we tried was, okay, how do we test if this is a solution? And if it is a solution, it should work, or it should make true statements when we substitute values in. Okay, so let's go ahead and do that here real quick. And make sure you guys are following along and ready to type in the chat, because I want you guys to make sure you're getting this, because I'm going to have you guys, we're going to do a little practice game here in a sec. Okay, sorry, I talked really low. We'll do a little practice game here in a second. So help me solve this one. We've got an x and a y coordinate here, right? This is x, this is our y. X comma y, x is 1 and y is then -2. And it says, is the point a solution to the system? Or is this coordinate pair a solution to the system of equations? Well, we know our x is 1, so I'm going to fill that in. And we know our y is -2. Okay? And I'll go ahead and let you guys answer in the chat. What is the first thing that we do? What's the main thing that we're going to do to check and see if this is a solution? What do we do? Once we realize what the x is and what the y is, what do we do with that x and that y, class? Take those values, and what do we do with them? Okay, good. And I said place them in the equations. And do you agree or disagree? All right, good, excellent, guys. You take the values and you're gonna plug them in, or place them in to your equations. Okay, and the mathematical term is substitute them in. Just like a substitute replaces something, like if a teacher's gone, you have a substitute teacher. So I'm going to replace these two y's here, y equals 3x minus 1. I'm going to replace that with a -2. There's a y in that one, y equals -6x plus 4. I'm going to replace that y with the -2. Okay, anytime I see an x, I'm going to replace those with 1s. And then I solve. So I say, okay, well, this is 3 times x. Now it's 3 times 1. So 3 times 1 is 3 minus 5 takes me to -2. So this right side is -2. Oh, the left side is -2. So -2 is equal to -2. Yeah, it's a true statement. So this worked for this equation. Now we check the second equation. -6 times 1. -6 times 1 is just going to be -6, right? -6 plus 4 is going to get me to -2. Right? You start at -6, go 4 to the right, you're at -2. So this one also happens to get to -2 equals -2. Once again, of course, that's a true statement. Anything is equal to itself. So did this work for both of them? Yes. So is this point a solution to the system? Yes. okay? If either of these did not work out, like if the top one said -2 equals 5 or -2 equals -7, that wouldn't work. That wouldn't be a true statement. So it would not be a solution. Okay, it has to work for both. All right. All right, excellent. So, and we're gonna break this up each time. So that was the first thing that we went over. So we are going to do a mini little quizzes live. And I want you guys to go ahead and join me at joinmyquiz.com and use this code to enter. And see if I can join as well. Oh yeah, I can play. So go to joinmyquiz.com. The code's in the chat. You can use that if you'd like. I said Quizlet live, I think. I meant quizzes. Quizzes live. But if you go to joinmyquiz.com, guys, and enter that code, should be good. There we go. 065. All right. Says I'm in my screen. Okay, are you Graviola Gatsby? Maybe just try refreshing your page and doing it one more time. Oh wait. Okay, now I see it on the right. Poppy, it's like Poppy. Okay. All right, then let's go ahead and get started. That so it's only 5 questions. Take your time. Make sure you plug in those values, guys. If you need this paper, go ahead and grab them. job, everyone. Let me pause this for a sec. Good job. So that was the first thing that we learned, right? Just testing solutions. And again, it's helpful for answering questions just like that, but it'll also help for when you are solving systems of equations by graphing and you want to make sure that you have the correct answer. There's actually a couple other ways to solve systems of equations that you'll learn next year. One is called elimination, one's called substitution. And the substitution one, you're actually going to be just substituting different things into different places, kind of like we're doing here. So anyway, a lot of times in math, if you're solving for x or solving for a variable, you can check your answers by substituting the value back in. So that's basically what we're doing here, right? So good job, guys. That was the first thing that we learned in this this unit, right? And so now, sorry, I have to reorganize the screen here. So then the second thing that we learned was if we're given two lines, finding out what the solution is to that set. Okay, so what I'm going to have us do now, I'll give you guys the option. Would you rather have, would you rather do another quizzes or would you rather do a Kahoot for this section? Okay, we got to vote for a Kahoot. What do you think, Emma? Which one would you rather do? Kahoot. All right, let's do it. I'm going to put it on the screen here. So this is going to be the second thing that we learned, right? And share. So there's the code. Yeah, so this was the second thing where it was already graphed for us. Okay, so the first one was, is this a solution? Check the point. Then the second thing is, if the lines are both graphed, can we check what the solution is? Let's go ahead and get started. Solution of this system of equations. All right. So remember when we're looking at points, this is obviously where they're going to be connecting to each other, right? Where they intersect. And so we say, okay, 3 to the right, 2 up. So 3, 2. Okay, so, and just a quick note about that. It is maybe slightly confusing because we've been talking about slope a lot, where we do change of y, right, over the change of x. So the change in the up and down over the change in the left and right. But don't forget, when we're just talking about points, we go the x first, x comma y, right? So 3 comma 2. All right. All right, next question. What is the solution of this system of equations? Excellent. Nice. -2 comma -1. Good job. -2 comma 3. All right, what is the solution of this system of equations? Good job. No solution, right? Because they're not intersecting at all. They're parallel. And even if we want to check, like, because they might look like they're parallel, but they might slowly and end up hitting, you know, somewhere out here. Rise 2, run, actually, let's see, 1, 2, 3. Rise 3, run 2. Rise 1, 2, 3, run 2. Gets me to another point. 1, 2, 3, 1, 2. Rise 3, run 2. Okay, they have the same slope. So, all right. Next question. Excellent work. 4 comma -1. So 2 to the left and down 1, so -2 comma -1. Ready. So on this one, again, we're trying to find our intersection, which is right here. So we start at the origin and we say 1 left, 3 up, right? X comma Y. So 1 comma 3. Okay, so that would be blue. Right? So here's our intersection point of intersection, right? And again, guys, remember to do x comma y. Okay, x is left and right, y is up and down, so we have to do the x first. Okay, so that means we go left 1, 2, and then we go 0 up or down, right? So -2 comma 0, we're not going up and down. So that would be green, -2 comma 0. Yeah. Right, x, make sure you do the left and right, the x first. All right. What is the... Right, you guys got that one well. And just a reminder, there's not one on here, but if there were 2 lines that were right on top of each other, Okay, so if there was a blue line here and a red line right on top of it the whole way, then it would be infinitely many solutions, because it's saying how many times does it intersect? Well, here and here and here and here and here and here, forever, right? So there's an infinite number of solutions if it was 2 lines on the same spot. Okay, but these don't ever touch, so this one's no solution. All right. Let's see, podium. Nicely done. You guys are doing a bit better. I don't know if you're like me, and I've made some mistakes on a couple of these and the quizzes, so don't feel bad either way. All right, so okay. Excellent work. So that was the second thing that we did, is if they're already graphed, can we find what does the solution look like? You know, it's where the 2 lines intersect, and can we find that spot? Okay, which we just did, where we say, okay, you know, 3 to the right, 1 up, -2 to the left, 0 up or down. That's all we have to do, is basically know that point and label it. Okay. Any questions on that? Let me pause real quick, because we did have a little bit of trouble on that. Any questions on how to find a point of intersection and label it? Okay. All right. Okay. If you do, just let me know. Okay. So then the last thing that we talked about was doing the graphing ourselves, right, and finding the solution. So if we just have 2 linear equations, and can we graph them both and find out where they intersect, find out where the solution is, right? So I'm going to pull up, this is going to be our last thing here. I'm going to pull up our little IXL practice that we did. Okay, and it was AA2. If you want to open up a tab and go there, you can do that as well. But let me share my screen with you. And I just kind of want to walk through. This should work. Okay, I just kind of want to walk through 1 or 2 of these together to make sure that we're all on the same page and that we're all understanding it. So I really like the tool on here. It's kind of similar to what we did with the Desmos activity. So it just gives you your 2 equations, and then it wants you to graph them both on the coordinate plane, on the graph first. Okay, so first one is y equals x minus 5. So I'm going to press on my y equals x minus 5 down here. And if it is y equals mx plus b, right? That's the form of a linear equation. I'm going to write that in the chat. Y equals mx plus b. Okay. Real quick, I want you guys to tell me, what does the m stand for in that linear equation slope-intercept form? What does the m stand for, and what does the b stand for? So the question's in the chat. What does the M and the B stand for? Because if you know that, then these problems won't be a big deal, and you'll do very well. Okay, so I want them not to be a big deal for you guys. I want them to feel easy. So what do you think? Once you think you know, go ahead and respond in the chat. Okay. Good, thank you, Emmett. What do you think, Edna? Okay. All right, so y equals mx plus b. The x and the y are going to stay open, we'll say. They stay as variables because anywhere along our line, we should be able to plug in a x value and a y value, right? Like a coordinate pair, x comma y. We should be able to plug in any point along our line into our equation, and it should make a true statement. So that's why when we graph two lines, we should be able to take any point where they intersect, and it should go into either equation and make true statements. So the x and the y stay open, and so the m represents the slope, how tilted your line is, right? And b represents where it hits the y-axis, to y-intercept. Okay, so make sure you practice that, you learn that. Very, very common. You're gonna be using that next year as well as, of course, this year we've used it quite a bit as well. So y equals mx plus b, where m is the slope, b is the y-intercept. As long as you know those two things, then this should be pretty easy. So then we look at our equation here and we say, okay, y equals mx plus b. All right, the m, if there's nothing there, then it's going to be a 1, right? Because we have an x. So y equals 1x, and then plus b. And then so whatever's on the end is your y-intercept. So instead of a plus b, this is a minus 5. So I say, okay, my y-intercept, is going to be at -5. So I start at 0, 0, the origin, and I go down 1, 2, 3, 4, 5, place my point. And if my slope is 1, if I have to write that as a quote-unquote fraction, then I would say 1 over 1, right? So that would be a rise of 1, run 1, rise 1, run 1, rise 1, run 1, rise 1, run 1. Okay, so anywhere along there I could have placed my line. And my line's going to look like that. Okay, then I go to my other equation, I click down here, and I say, okay, where's my y-intercept? It's at positive 3, right? So I start at the origin, 1, 2, 3, place my point. Then my slope, again, there's no number out front, but there's a negative. So this time it's going to be -1. So my slope, if I were to write it, let me put it in the chat, would be -1 over 1. Yep. Our slope is -1. And if I want, again, quote-unquote fraction, the only reason we put it over 1 is because we want to be able to say rise over run. So if it says rise of -1, that's not really going to be a rise, it's going to be going down, but we call it rise. So a rise of -1 and a run of +1. Rise of -1, a run of +1. So down 1, right 1, down 1, right 1, down 1, right 1, down 1, right. Okay. And then it would make a line looking like this. Okay, with this graph thing, it's really nice. We only have to put 2 points. So we've got a green line and a kind of a pinkish purple line, fuchsia. And they intersect, it looks like at 4, comma, -1. So then I say 4, and I say -1, enter, and we got it right. Okay. What I want you guys to do is we're going to do, let's say, 2 more of these. And I want you guys to either have your set up, your AA2 set up so you can try in just a sec. Or I want you guys to, well, sorry, let me rephrase that. I want you guys to ask any questions on this and follow along in case you're not understanding. And yeah, and make sure to ask questions so I can try to help you. If you don't have questions, make sure you're following along, and then I'm going to have you guys try a couple, okay? All right, so this one we've got y equals mx plus b, y equals mx plus b, right? They're both linear equations. Let's graph the bottom one first because it looks a little easier. Okay, so we've got y equals -3x plus 4. And the y-intercept is at +4, right? So I start at the origin, 1, 2, 3, 4, place my point. Then my slope is -3, right? If I had to write that as a fraction, right, I could say -3 over 1. So that would be down 1, 2, 3 over 1. So rise of -3, a run of +1. A rise of -3, so that's down 3, 1, 2, 3. And a run of +1, that's going to be 1 to the right. So I go down 3, right 1, down 3, right 1. And I get here. Okay, good question. Okay, so that first one, so we did our second one, right? Now this one doesn't seem to have a y-intercept, does it? So what's the only number, because all of these have to have a either a slope or a y-intercept to some degree. Yeah. Let me make sure I'm saying that right. Yeah. What's the only number that you could have that would not show up, that would not show a y-intercept? Okay, so it would have to be 0, right? If we had y equals -x plus 0, I'll write this in the chat. If we had y equals -x plus 0, think about that for a sec. I could write that, but then plus 0, does that really do anything? Nah, not really. So then I could rewrite it as y equals -x. Okay, that's what they've done. So then there's actually a plus 0 there, but 0 doesn't do anything. So that means it starts here at the origin, like you were saying, Emmett. Our y-intercept is at 0, so it doesn't go up or down any. It starts here at 0, 0. And then my slope, right, is a -1 because there's no number there. So -1 is my slope. If I had to write that as a fraction, I could say -1 over 1. And so that's a rise of -1, so down 1. So let me go down 1. And then a run of +1, so 1 to the right. Then we go down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. Okay, so then that's our line. And now I look, okay, where do they intersect? Looks like 2 to the right and -2. Yep, so that's my coordinate pair. X is 2, y is -2. So I come here and I say 2, -2. And we got it right. Okay, let's do one last one, guys, together. So I look at my first equation. What is my y-intercept going to be, guys, for that first one? Go ahead and answer in the chat. You guys there? What do you think? What's the y-intercept for that top equation? Okay, good. And what do you think? Do you agree or disagree, Edna? Agree. All right. So you guys are both correct. Good job. 2 is our y-intercept because it's y equals mx plus b. So we go up 2, place our point. That's where we start. And then we take a look at our slope, which is -1, right? There's no number. It's a -1. So again, if I have to write that, so I basically think this in my head. -1 is the slope. And -1 over 1. Good, Emmett. So I go rise of a run. So rise of -1, run of +1. So down 1, right 1, down 1, right 1, down 1, right 1. Okay. Following that rise over run tactic. All right, and then the second one. It starts at -4, it looks like, right? Make sure you take the sign with you. So it's a -4. Down 1, 2, 3, and 4. Place my point. My slope is a 1. They've got a lot of these, don't they? There's no number there, so it's a 1. 1 is slope. So as a fraction, that's 1 over 1. So it's a +1 of a rise and a +1 for the run. So up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1, right? And then we just look where they intersect and we say, all right, 3 for the x, comma, -1 for the y, right? So we would say 3, comma, -1. All right. Now, before I submit this, which that would be correct, we a lot of these haven't had fractions, and unfortunately, I don't think they always will. But if it was already 3/4 or something like that in front of the x, then you wouldn't have, like, let's say, and I'll write that in the chat. Let's say that suppose 3 over 4 was the slope. You wouldn't have to make it a fraction, so to speak, right? Because it's already a fraction. So you'd already have your rise of 3, run of 4. Rise 3, run of 4. If that was the case, all right? So if you ever see one that's a fraction, don't be like, oh, do I have to put it over 1? And then try to figure it out. It's already a fraction, okay? All right, good job. So let's go ahead. If you want to, you could practice a couple of these on your own if you think you need a little bit more practice before taking the CFA. Otherwise, I'll go ahead and post the CFA to the Google Classroom stream. The other thing, and you can get started on it right away, unless, like I said, unless you have questions and you want to work another one out together, which I'll be happy to do. Or if you are doing the IXL practice, you want to do a few more. Okay, that's your 2 options there, is get some more help in practice, or if you're ready for the CFA, take the CFA. The only thing with the CFA is there's a little video that you want to watch first. It just explains how to answer one of the types of problems that you'll see on the CFA. Okay, so I'm going to be posting that right now. So I would just hang on the Zoom call for now, and while I post this, and then if you have any questions, throw it in the chat there. Okay, or if you want to unmute, you can do that too. All right, so give me a sec. I'm going to post these. All right, and okay, so I'm going to go ahead and show you guys this real quick, how this problem works. And am I still sharing? Let's see. Oops. All right, share screen. All right. So when you get to one of the problems, guys, it'll look something like this. And it says, go to this link and use the graphing tool provided. So you would click on this link. Okay, it takes you to not the same IXL set we were doing, but a similar one. And it'll have you, you can use this graph, okay, to graph your equation. Okay, so let me set or your system. So we're using this as a graphing tool. So when you get here, guys, ignore this. Okay, I'll say that again. So you get to a question on your CFA, it says go to this link. You click on that, it takes you to this graphing tool. Ignore these equations, okay? These aren't for us, right? We're just using this graphing tool. So we look at our equation and we could say, okay, y equals negative 3x minus 1. So we'd say negative 1 and 3x. So rise 1, 2, 3, write 1. And then we go to the other one and say, okay, it starts at 3 with a slope of 1. So it starts at 1, 2, 3 with a slope of 1. Okay, and we would just do it like that and then answer the questions it says. So it says choose the x and y value for the coordinate point that is the solution to the system. So I'd say, all right, what's my answer? It's 2 to the right and 5 up, isn't it? So then I'd say x value is 2 and y value is 5, right? So then I click 5 here. And then I would submit. Okay? So that's how that question works. Any questions on that question? Okay. So I included a video on how to do that problem if you need to see it again.